Hello everybody. Today we'll be studying about a simple Rankine cycle. We can see the above diagram. In the vapor power cycle, the first one we will be studying about the Carnot cycle, which will be discussed later. Now we'll go through a simple Rankine cycle, which is mentioned here. So this is a simple Rankine cycle. You can see it. Okay. Simple Rankine cycle. Here I have drawn a simple Rankine cycle where the different parts which are containing here are, that is a steam generator, then a turbine, condenser to the working pump, then again once to the steam turbine. Now what happens here? In the steam turbine, initially you think that from here, from the feed pump, the water has been supplied. Yeah, it is, water has been supplied to the steam generator. And the steam generator, the boilers are playing a very major role. The boiler work is to generate the heat. Water starts boiling. Once the water starts boiling, it converted to vapor. The water vapors are converted to the saturated water vapor, where the water is getting heat is added. So vapors are ready. So saturated vapor is been sent to the turbine. Here what does the turbine does? It uses the steam turbine, the steam and flows on the blade. The turbine starts rotating, right? The turbine starts rotating, the work of the shaft is done. So the turbine starts rotating, shaft starts rotating, then the shaft output is sent to the generator, then electricity is produced. Then the steam coming out from the turbine is been sent to the condenser to cool down the fluid what has been entered here. Then the steam is been condensed from 4 to 5. Then the condensed steam is again sent to the pump, that is a feed pump we call. That feed pump sends the liquid to again to the steam generator. Now let us look after this, let us look after one by one. The steam generator is a one where heat is added, so we give it as a positive. As we already learned in the work and heat, what do you mean? What I'm talking about, heat in, heat out, that is work done positive, heat generated positive, negative, that all I hope you all remember. Okay, then in the steam here heat is added, that is a positive. Here work is done by the system, it is positive. Condenser heat is rejected, is negative. There is a heat out. Work done by the pump. Okay, we are forcibly working on the pump here, not by the pump, sorry. For work is done on the pump, so it is negative. Then the fluid is sent to the steam. Here you can see that simple TS diagram. I just mentioned 1, 2, 3, 4 and 5. That is from 1 to 2. 1 to 2, where you can see here actually is your boiler, turbine, condenser, and here is the pump. From pump, the fluid is supplied to the steam generator, that is then sent to the boiler. From here, from boiler to turbine, the steam is been sent for rotation. Work is done by the turbine. Then here condensation takes place, that is the heat is rejected. Heat is added here, heat is rejected here. Then the pump work starts here, the feed pump, it supplies the fluid to the steam generator. Okay, you can see here there is a boiler, turbine, condenser and a pump. Initially what is, as per the first law of thermodynamics, what you studied in basic thermodynamics, that is when the summation of cycles, that is net work done is equal to the net heat output, whatever the heat is done, that should be equal. From the steady flow process, okay, that one by one we'll see. In a steam generator, okay, you can see that, right, here in the steam generator, that is the work heat in, sorry, the heat in, that is H3 minus H1, that is positive. The heat is in here. Okay, here you can see H3 minus H1, because H3 is the, yeah, it is greater and this is lower, that is higher minus lower. And based on that theory only I have just written it here. H3 minus H1 is a positive. In turbine, that is the work done by the turbine. You can see here H3 H4, H3 minus H4, H3 is higher, H4 is the lower one. So same way H3 minus H4, that is a positive, work is done by the turbine, right? Then in the condenser, the output, you can see here steam coming out as H4. Here also you can see just numbers here, numbers are different, but don't worry, the numbers doesn't make any difference. Okay, here from here 4 to 5, higher, lower, correct? Higher, lower. So because based on that, H4 minus H5, that is negative. The reason is, yes, it is losing the heat. So heat is lost here. Pump work H5 minus H1 here. Okay, H5 minus H1. Yeah, H5 minus H1. Yes, H5. It should be H1 minus H5. Yeah, sorry. Okay, here H1 minus H5. You can see over here. That is, this is higher. This is at the lower end. This is a condition. Then what we need to find, that is the thermal efficiency in the given process. This is the process. This is the vapor power cycle, Rankine, simple Rankine vapor power cycle, and we need to find a thermal efficiency in this one. That is eta is equal to net work done by heat in the gas power cycle. That is the work done is equal to efficiency is equal to work done by heat supplied. The same is net work by heat in. The net work is here H3 and H4 plus H5 minus H1. Why this plus has come? Yes, here the work is actually done with respect to work done by the turbine minus work done by the pump. Since it is the negative here, because that is the sign here reflecting. This is nothing but work done by the turbine. This is work done by the pump, and WT minus WP is only the negative has been replaced by positive, since here it is negative, right? So therefore H3 minus H4 is equal to, we just rearranged again, minus H1 minus H5 by H3 minus H1. Okay, this is the efficiency. Now how to find a pump work? Here pump work can be calculated as follows. That is from the steady flow energy equation we have studied. This equation you have been through. That is delta WP is equal to minus DH. Now what is this DH? Yeah, enthalpy, correct? Yeah. The DH is been replaced by, that is TDS is equal to DH minus VDP. This is the equation which already seen in the work power cycles in a BTD, right? Now TDS is equal to DH minus VDP. Then this DH is been replaced here, but the TDS, as it is the isentropic process, that is the pump is a isentropic, so DS is equal to 0. That has been given by delta WP minus VDP. So pump work is equal to minus VS, negative sign as it has come here, because work is done, yes, on the work is done on pump. Minus V5 is into P1 minus P5, higher minus lower, P1 minus P5. You can see here P1 minus P5. If you draw a PV diagram, you will come to know that. So higher minus lower. So therefore steam rate is given by 1 kilowatt is equal to next. This is the how to find a pump work. If I want to find the steam rate for a given, so the steam rate is given by 1 kilowatt is equal to 1 kilojoule per second. That is nothing but 3600 kilojoule per hour. Steam rate is given by 3600 divided by net work done. That is nothing but kg per kilowatt hour. This is the steam rate. It's a simple Rankine cycle where there is no, I think there is no much confusion in this. You can easily go through. So immediately I'll upload another one, that is on a reheat and a regenerative. If any doubt is there, you can just contact me back. Thank you.